Hi guys, welcome back to my channel. Today we will be discussing the questions and answers from the previous 30 years GATE question papers with respect to the topic properties of determinants and inverse. In the last video we discussed the questions from the basic properties of matrices section. I hope you have already gone through it. If not, please watch and share your thoughts. So without wasting much time, let's quickly start today's discussion. So the first question we'll be discussing is the determinant of the matrix 0, 1, 2, 3, 1, 0, 3, 0, 2, 3, 0, 1, 3, 0, 1, 2. So we have to find the determinant of this particular matrix. It's a 4 by 4 matrix. So what we have to find is first we have to put the symbols. Like we know first the first element of the first row, which is 0, so we are not considering it. The second element is 1, so we are putting -1 into, so we avoid that particular row and that particular column, and we are finding out the determinant of the rest of the matrix, that is 1 3 0 2 0 1 3 1 2. The same rule we are applying to the next sections also. Like we are putting minus sign first and then we go with plus minus, as you all know. So this is a very simple question, and this was asked for 1 mark in the previous year's papers. So I think you are almost clear with it. The answer we are getting is 88, and this is a part of the numerical questions. So so let's move on to the next question. Determinant of the following matrix is what? So this is a 3 by 3 matrix, which is very simple. So how to find it? Just put the first element of the first row, that is 5 into the matrix of the 2 by 2 matrix, which is 2 6 5 10. What is that? 2 into 10, which is 20, minus 6 into 5, which is 30. So 5 into 20 minus 30 minus 3 into 10 minus 18 plus 2 into 5 minus 6. I think you are already thorough with the basics of how to find the determinants of 2 by 2, 3 by 3, 4 by 4 matrix. So once you are done with it, it's very easy for you to find out. These all are like direct questions which were as in the previous papers of GATE. So we are done with it. The answer we are getting is minus 28. So the correct option will be option B. Next is a question which they want to test, like are we clear with the basics of the determinants? Let me read the question. If A and B are square matrices of size n by n, then which of the following statement is not true? So the question is, which of the following statement is not true? It's not like the which of the following statement is true. So let's read one by one. Determinant AB is equal to determinant A into determinant B. Option B, determinant, or not the option B, I'm saying the statements. The statement B, determinant K into A is equal to K raised to N into determinant A. Determinant A plus B is equal to determinant A plus determinant B. Determinant A, I think they have given it as A transpose, some printing error was there, is equal to 1 by determinant A inverse. So when we, if we are thorough with the basics or the properties of matrices, determinants properties, I'm sure you will be getting, like we know C is the option which is not true, like it's a false option. Determinant A plus B is equal to determinant A plus determinant B. It's not the way we are finding out determinant A plus B. So the correct option for this will be option C. Next question, if the determinant of matrix 1 3 2 0 5 minus 6 2 7 8 is 26, then the determinant of the matrix 2 7 8 0 5 minus 6 1 3 2 is what? So we know when we interchange any row or a column of a matrix, the value of the determinant will be the same. So we don't want to worry about anything, we don't want to worry about any sign or anything. if we are interchanging any row or column of a particular matrix, the determinant remains the same. There is no change in it. So the answer we are getting is 26. It's the option B. Number of terms in the expansion of general determinant of order n is what? So this we all have learned, like number of terms in the expansion of general determinant of order n is n factorial. The determinant of matrix is a sum of n factorial terms where each term is a product of n different factors of element of a matrix. So the answer we are getting is n factorial. So just remember, when we take a matrix. So the next question is, for the given orthogonal matrix Q is equal to 3 by 7, 2 by 7, 6 by 7, minus 6 by 7, 3 by 7, 2 by 7, 2 by 7, 6 by 7, minus 3 by 7. So in the question itself, there is a clue lying in that. So we have to find the inverse of this particular matrix. So we know for an orthogonal matrix, what is that? For an orthogonal matrix, the inverse is equal to the transpose of that matrix. A inverse is equal to A transpose, and A is considered to be an orthogonal matrix. So directly we can find out the inverse of this matrix, which is row wise I am reading 3 by 7, minus 6 by 7, 2 by 7, then 2 by 7, 3 by 7, 6 by 7, 6 by 7, 2 by 7, minus 3 by 7. So if we find out with the general formula also, that is adjoint Q by determinant Q also, we will be getting the same answer, but it's a lengthy process, that's it. So if we are thorough with the basics, as I said earlier, like the orthogonal matrix, what are the properties of the orthogonal matrix, then this is a simple question for you. Next question, the inverse of the matrix A is equal to, this is a 2 by 2 matrix, minus 3, 5, 2, 1. So what is inverse of a matrix? It's adjoint A by determinant A. So what is adjoint? Adjoint is, we know, just find out, just interchange those two, minus 3 and 1, and just put the opposite signs of 5 and 2. So we are getting 1 minus 3 minus 5 minus 2. So A inverse is adjoint A by determinant A. Determinant A, we are getting it as minus 13. So this is equal to 1 by minus 13 into 1 minus 5 minus 2 minus 3. Next question, inverse of matrix 0, 1, 0, 0, 0, 1, 1, 0, 0 is what? So inverse of the given matrix A is A inverse is equal to, like just we want to do the transpose of that from the properties of the matrix. Through the general way, that is by the formula also we can find out adjoint A by determinant A. So adjoint through the cofactor matrix, we are finding it out as adjoint of A is transpose of the cofactor matrix, which is which it's given here, and A inverse is adjoint A by determinant A. So the answer will be 0, 0, 1, 1, 1, 0, 0, 1, 0. Moving on to the next question, the inverse of the 2 by 2 matrix 1, 2, 5, 7 is what? So just find out the cofactors. Cofactors, the easy way we all know, as I said earlier, or otherwise you can find out like this. So we are getting 7 minus 2 minus 5, 1. That's a adjoint. Adjoint A is 7 minus 2 minus 5, 1. And just find out the value of determinant, which is 1 into 7 minus 2 into 5, which is 7 minus 10, which is equal to minus 3. So A inverse, we are getting it as 1 by minus 3 into 7 minus 2 minus 5, 1. So 1 by 3 into minus 7, 2, 5, minus 1. Next question, the inverse of the matrix 3 plus 2i minus I 3 minus 2i. So these are not real numbers, these are complex numbers. So we have to find how to find the inverse. Same like adjoint A by determinant, adjoint by determinant of that particular matrix. So adjoint, we are getting it as just interchange those two values, 3 minus 2i, 3 plus 2i. The other one just interchange the put the negative signs minus I and plus I. So we are getting determinant A is equal to 3 plus 2i into 3 minus 2i minus I into minus I. The determinant A, the same like how we are doing it, cross multiplication. So it's 9 minus 4i square plus I square, which is equal to 9 plus 4i square we know, which is minus 1. So just substitute that. We are getting the determinant of matrix A as 12. So A inverse is 1 by 12 into 3 minus 2i minus I 3 plus 2i. Next question, the inverse of the matrix 2, 3, 4, 4, 3, 1. 1, 2, 4 is what? So this is a general matrix and it's a 3 by 3 matrix. So we have to apply the formula adjoint A by determinant A. So these are direct questions, very direct questions. We just want to know the formula. So just remember this formula. This is adjoint A by determinant A. Determinant A we know how to find for 2 by 2 matrix, 3 by 3 matrix, or 4 by 4 matrix. And we know adjoint of a matrix is the transpose of the cofactor matrix. We also know to find out the cofactors also. So the answer is determinant A, we are getting it as minus 5. Then we have to find out all the minors and then the cofactors. Then we are getting the adjoint A, which is a transpose of the cofactor matrix of A. So A inverse is equal to adjoint A by determinant A, which we are getting the option C as the correct answer. So I hope everyone is clear with all these questions. These are very simple questions. Just you just want to be thorough with the formulas and the basic theorems and properties. So in the last video also I mentioned for the properties of matrices, just apply those properties. You will be getting easily. You can score the 1 marks, and even for 2 marks also in some years they were asking the questions, simple questions. Just want to know, are we thorough with the concept? So thank you guys, thanks for listening. You can share to your friends or whom, or to those this will be helpful. And you can also subscribe, like and comment. Is there any from like the suggestions, and is there any request from their end for the upcoming videos, like for the suggestions for the videos, like what kind of videos you'll be expecting? Will you be expecting more on the theory part or the question parts? So as of now I am concentrating on the previous year question papers. So these are the basic questions, or these are the questions from the last 30 years question papers. So thank you guys, thanks again.